This is 4.5. Multiplication and division with complex numbers. Our objective today, guys, is students will be able to multiply and divide complex numbers. So in our previous lesson, we talked about addition and subtraction, which is the easy one. Complex number, however, are a little bit more complex when we're multiplying and divide. So the set of complex number is always closed under the operations of multiplication and division, except by zero. All that means is that when two complex numbers are multiplied, their product is another complex number. And it's similar for division. Multiplication can be done by the box method, which we learned already, or some of you guys know the FOIL method. Whichever method you will do, you will get the same exact answer. So one thing that we need to remember for this is, what does I square represents? I square is -1. So really quick, remember our ice cream scoops? We had 1 scoop here, 2 scoop here, 3 scoops, and 4 scoops. We said this was my I, this is my -1, this is -I, and this becomes +1. So that's my little ice cream scoop. Ice cream. Okay, box method, which I love, 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 just as you would be multiplying two binomials. Set this up: 3 plus 5i, 7 plus 2i, and I want to fill in my boxes. So 7 times 3 is 21, 7 times 5 is 35i, 2i times 3 is 6i, 2i times 5i is 10i square, just like you would normally get x. Now I want to combine my like terms. You're going to get 21 plus, what's 35 plus 6 is 41, oops, not 40i, 41i plus 10, and we know I square is -1, so this becomes 10 times -1. This can be simplified as 21 plus 41i minus 10. And then I want to simplify this, so let's just move this up just a little bit so I can have some space. And let's combine our like terms. So it's 21 take away 10. This becomes 11 plus 4, 41i. And that's my final answer. So with multiplication, you will get another complex number. How do I know it's a complex number? It has the I. Let's try one more example. A 2x2 grid again. -2, keep the signs just like you practice when you're multiplying binomials. 3 and -2i. This becomes -6. 6 times 3 is 18i. Negative times a negative is a positive. This becomes, what is this? What did I write here? 2 times 2 is a 4i. This becomes, why does that I look like that? This is an I. 4i. And then -2i times +6i is -12i square. So I want to write this out. This becomes -6, and I want to combine my like terms. (18i plus 4i is plus 22i minus 12i square. Now I know I square is -1, so it'd be -6 plus 22i minus 12 times -1. This becomes negative 6 plus 22i plus 12. Negative times a negative is a positive. Again, let's just bring this up here. Move this a little up so I can write in the bottom. So my final answer turns out to be, combining like terms, negative 6 plus 6 is a positive 6 plus 22i. And that's my final answer. I want you to pause the video, try letter C by yourself, and tell me what you get. No, pause the video and tell me what you get. Let's compare answer. Alright, you should have gotten negative 17 minus 17i. Again, distribute, combine your like terms. Negative 20 minus 17i minus 3i square. Remember, I square is negative 1, and go ahead and simplify. Look through the step by step and see how it goes. So, we're going to talk about complex conjugates. Why am I stuttering today? Your conjugate is the same exact thing that we've seen before. Remember the a square minus b square thing, and we would get an a plus b and a minus b. That was my conjugates. I'm looking at that again. So, for our second exercise, we are going to go ahead and find the product of these conjugates. How do I know they're conjugates? It's the same a and b, and I want to multiply these out. So just like what we have been doing just now in our previous exercise, go ahead and multiply this. I'll do the first one with you, and then you're going to go ahead and do the other two by yourself. This becomes 4, negative 2i. So let's fill these boxes in. 16, 8i, negative 8i, and then this is minus 4i squared. Negative times a positive is a negative. Now combining like terms. My 8's with the I are my like terms. So I will end up with 16. 8i minus 8i is 0, so that cancels off. And then I have minus 4i squared. But we know that I squared is actually negative 1, so this becomes 16 minus 4 times negative 1, and I'm just going to write it out here. This becomes 16 plus 4, which is 20. Now go ahead, work these box method out for B and C, and let's compare answers. Pause the video. Alrighty, for B, you should have gotten 26, and for C, you should have gotten 45. I want you to make sure you look at this step by step, go through each step that I did to make sure you got these answers. Now, exercise 3 says, what is true about the products that you found in exercise 2? What did you notice about these 3 questions versus these 3? What did you notice? Yeah, you should notice that these in question 2, all the answers are real numbers because the imaginary part, which is the one with the I, the imaginary part cancel each other. So because of the differences square, these imaginary parts here, negative 5 plus 5i, they cancels each other. 8i minus 8i cancels each other. 18i minus 18i cancel each other. So that's why I always get a real number, because I know I square is negative 1, which I have been substituting. Now for exercise 4, it's a little proof which looks something like this. So for the proof, it's a little proof that says something looks like this. Why is that a plus bi, when I multiply it with its conjugate, I always get a real number? Basically, it's what we did here. You FOIL it out, we saw that the imaginary part cancels each other off, and I'm left with something that looks like a square minus b square I square. I know I square is -1, so when I do a negative times a negative, it will always give me a positive. So I end up with a squared plus b squared, whatever is my a and whatever is my b. So since a and b are real numbers, as in our previous definitions, the expression a squared plus b squared will always be a real number, meaning there will be either a positive or negative number. It will be a real number. Exercise 4. Consider the division given by 3 plus 2i divided by 4 take away 5i. So the first thing we want to just really recap really quick is that when you're dividing by a complex number by itself, always remember that anything divided by itself is always going to be 1. So letter B, write the original quotient in simplest a plus bi form by multiplying the fraction. So this is where this is the hardest as it gets with complex number. So my original division was 3 plus 2i over 4 take away 5i. Now when we're dividing, what we want to do is multiply by the conjugate. What does the conjugate mean? What's the conjugate of the denominator? The conjugate of the denominator is going to be the 4 plus 5i. You multiply by the conjugate. So if this was a plus, this would have been a minus. And I multiply by the same thing on the top and the bottom. Now what does that do? It makes my bottom, I'm just going to shift this over here so I have, again, space. What this does is I am going to multiply across, multiply at the bottom because they're the same denominator. This is my conjugate pair, just like in my previous example where I proved that conjugate pairs are going to be the A's and the B's. Now, what do I mean? I should write this at the bottom, just because I'm going to need a lot of space. So this at the bottom, it goes back to my example over here. It's always going to be the a square plus b square. What's my a? This becomes 4 square plus my b square, which is 5 square. The top now, I need to do that in box method. Multiply the top, my numerators, 3 and 2i, and this is 4 and 5i. So let's fill this in. 3 fourths, 12, 8i, 15i, 5 twos, 10i square. So this becomes 12 plus 23i plus 10i square. We know that I square is equal to -1, so we're going to replace this as 12 plus 23i plus 10 times -1, and my final replacement will be 12 plus 23i minus 10. And then what do? I combine like terms, the 12 and the -10, minus 10. So 12 take away 10 would be 2 plus 23i. So my top fraction ends up to be 2 plus 23i. Now how can I simplify this? What is 4 square? This becomes 2 plus 23i. Let's simplify my denominator. 4 square is 16 plus 5 square is 25. this becomes 2 plus 23 over I. What 16 plus 25 is 41. And you can leave your answer at like this, or I like to write it as 2 over 41 plus 23 over 41I. And this is my final answer. Now we have 3 more to do. Let's see how we can get this done. Alrighty, so again, let's see how this works. I know it's a little long, but let's work on this. So again, I want to divide the quotient in the simplest form. So multiply by the conjugate, which is 5 plus 3I. This becomes 5 plus 3I. Now multiply the bottom. The bottom will gives me 5 square, remember the shortcut, plus 3 square. The top now, I'm going to do the box method over here and then I'm going to erase it. You copy this as we go. The box method now for the top, or those of you that like FOIL can go ahead. Negative 4I, 5, and a 3I, positive 3I. We're going to fill this in as 10, negative 20I, 6I, negative 12I square. This is 10 minus 14I minus 12I square. These are my like terms, remember that. 10 take away 14I minus 12 times negative 1. 10 take away 14I plus 12. This works out 10 plus 12 is 22 minus 14I. So my top works out to be 22 minus 14I. Now let's simplify the bottom. 22 minus 14I, simplify the bottom. 5 square is 25 plus 9. 3 square is 9. This gives me 22 minus 14I over 34. And remember how to simplify these down. So this now would be 22 over 34 minus 14 over 34I. And because it says to simplify it, you have to simplify these fractions. All you have to do is put this fraction in the calculator by itself and hit enter. You will get your final answer as 11 over 17 take away 7 over 17I. And this is my final answer. Once you get up to this point, plug 22 over 34, hit enter, you will get 11 over 17. Bring your minus sign down, you will get 14, plug in 14 over 34 and you will get 7 over 17 and bring your I down. So I hope you got all of that. What we're going to do, I'm going to clear this out and we're going to do B. Make sure you copy this, okay? So I'm going to take all of this out and we're going to do B. Oopsie, here we go. With B, first always start off by multiplying with the conjugates. 10, this should be a plus. We're doing the conjugates. Bottom becomes 4 square plus 10 square. Now for the top part, I'm going to do the box method on this side. What do we have? We have 22, 3I, this is positive, and 4, and a positive 10I. This is a 10I. Okay. So let's fill this in. This becomes 4 times 22 is 88. This becomes 12i. This becomes 220i. And 10 times 3 is 30. I times I is I squared. So combining like terms, I got 88 plus 232i plus 30i squared. This is 88 plus 232i plus 30. I squared is -1. So what am I left with? 88 plus 232i minus 30. Combining like terms, 88 take away 30 is 58 plus 232i. So my numerator end up to be 58 plus 232i. Now let's simplify the bottom. The top is 58 plus 232i. 4 squared is 16 plus 100. This becomes 58 plus 232i over 116. And remember, just give each fraction their own part. 58 over 116 plus 232 over 116i. And remember, the question says in the simplest a plus bi form. So put this in the calculator. What is 58 divided by 116? You will get this as half plus 2i. 232 divided by 116 is 2. And this is your final answer. Let's go ahead and try the last one. I am going to take all of this out and try the last question. Letter C, which is all the way up here. So, C, first thing, remember, conjugates. 3 minus 4i, 3 minus 4i. This is going to be 3 squared plus 4 squared. So let's work the top part of it out. Get my box method. This is 10 minus 5i, 3 minus 4i. Fill this in. 30 minus 15i minus 40i, and this is a positive, I don't need to write plus, but oh well, 20 squared. So the top, we're going to write it here as 30 minus 15i minus 40i plus 20i squared. And then I'm simplifying it. 30 minus 55i plus 20, and I know I squared is -1. 30 minus 55i minus 20. So what's 30 minus 20 is 10 minus 55i. So this is my numerator, which we're going to put here. 10 minus 55i. Now I want to go ahead and simplify this. I'm going to give 10 minus 55i. 3 squared is 9 plus 16. This becomes 10 plus 55i over 25. Now remember, simplest form means I'm going to break this down. 10 over 2 plus, not 2, 25, sorry. 10 over 25 and 55 over 25i. Again, simplest fraction because that's what they asked me for. Put 10 over 25 in the calculator, hit enter, you get 2 over 5 plus 11 over 5i. Again, on the calculator, and I'm going to make a note in the side, calculator, calculator, can't spell today. You go to control and division sign. You will get something that looks like this. In the top, you want to enter 10, and in the bottom, you want to enter 25, and then hit enter. And you're going to get 2 over 5, and that's where this number came from. Alrighty, just take it easy, take a breath. I know you can get the practice problems done, so go for it. And remember, I know you can do it, you can do it. See ya!